Okay, in this tutorial we're going to be looking at quadratic polynomial functions. Okay, so we've got a few different forms. Okay, so our general form is y equals ax squared plus bx plus c. Okay, we also have a quadratic in the form that's known as the turning point form, which is y equals a outside of x take h squared plus k, where our turning point is at the point hk. So our turning point ends up becoming hk. Now, intercept form, okay, is y equals a outside of x take n times x take m. Okay, so we'll just talk about some of the different forms and what actually we can look at. Okay, so the discriminant for our general form. Okay, now remember the discriminant from our previous tutorials is delta equals b squared take 4ac. Okay, and if the discriminant is less than 0, we're not going to have any intercepts. So that's what would be happening here. If we took the discriminant of this function, okay, we'd see that that's not going to, there's going to be below 0. If it's equal to 0, we're going to have one intercept. So that just means that it'd be something like this, where our turning point is at the x-axis. Right, and if the discriminant is bigger than 0, we're going to have two x-intercepts. Okay, so it's going to look like this. Okay, when we look at our turning point form, the main thing to remember here, okay, it's quite a useful form. If we need to change from our general form to our turning point form, then we need to do that by completing the square. Okay, which I'm not covering in this video. Okay, but yeah, it's a process that you need to use. Okay, and the turning point for our intercept form will always be halfway between n and m. Okay, so our parabolas or our quadratics, so that take on our parabolic form, okay, are symmetrical about the turning point. So our intercepts will always be the same amount either side of it. Okay. Now what does the a do? Okay, so we can see we've got a's in here. Okay. Now we're not worried about the fact that we've got dilations and reflections and translations in here. Those type of transformations are covered in a later tutorial. All we're worried about now is that if a is bigger than 0, so if a is positive, then the graph is positive and said to be concave up. Okay, like this, concave up. Okay, if a is less than 0, then the graph is negative and said to be concave down. So be down this way. Okay, so we're just going to have a bit of a look at a couple of examples here on quadratics. Okay, so things to remember when it comes to sketching graphs. Okay, the y-intercept, the x-intercepts, the turning point, or max and mins when we talk higher functions, okay, and any endpoints. Okay, so for here, okay, our first one is we want to sketch the function f of x equals 3 outside of x take 2 outside of x plus 4. Okay, so what we need to do here, okay, is realise that these are going to be our intercepts. All we're going to do is switch our signs here. So we're going to go through the point 2, okay, and the point -4. Okay, now I'm breaking my own rule here because I haven't actually drawn a scale on here at all. Okay, so when you sketch a graph, make sure that your scale on the x is the same whether it's positive or negative. The scale on the y is the same whether it's positive or negative. But remember, our scale doesn't have to be the same on the x and y. Okay, so we've got those 2 points there. Now the other thing that we need to do though is realise where's our turning point. Well, remember, our turning point is going to be halfway between these two. Okay, and halfway between -4 and 2 is going to be -1. Now we don't actually know what that value of the y value, sorry, of our turning point is. Okay, so we need to actually sub this -1 back into our equation. So if we say y equals 3 outside of -1 take 2 and -1 plus 4, okay, well we have y equals 3, okay, so we've got -1 take 2 is -3, okay, -1 plus 4 is +3, okay, so we're going to be a y-intercept of -27. Sorry, the y point of our turning point is -27. I'm going to move it out of the way so we can sketch it. So you see here, if I went the same scale, I wouldn't fit on at all. But I can basically just go plonk down here and say that that is going to be -27. And that's going to be our minimum. Okay, so now I've got everything I need to sketch my function. Okay, so things to remember, okay, when sketching it, okay, is that it's symmetrical, Okay, it needs to be one solid line. Okay, now I might be slightly off on this one today, okay, but we need to make sure that we're reasonably symmetrical, which I'm not here. Okay, and that'd be because my scale is probably not quite right there. Okay, which is hence why you need to space it out properly. Okay, what we don't want to see, examiners don't want to see, is this sort of thing where you've kind of come along like that. Okay, it's not nice and clear. Okay, and it's also really important, okay, to sketch all your graphs in pencil. So you can do exactly what I did just there with a whiteboard marker or being able to rub it out. Okay, our next example we're going to look at is find the equation of the function below. Okay, so at the moment we can see that we've got our turning point, so it makes sense to use our turning point form of y equals a outside of x minus h plus k. Don't need a bracket there. Hey, we need to think about, okay, well, what's happening here? What do we know? Okay, well, we know our turning point is at 4, negative 10. And say, well, we've got y equals a, so that x minus 4. And remember, don't make that a plus, you've got to switch your sign. Okay, minus 10. Okay, but we've still got this a value that we've got to sort out. And on inspection, you might be thinking, oh, geez, I don't have any other information that I can use. Okay, but we actually do. It's the fact that we're going through this point here, going through the origin. Okay, which works out quite nicely for us. So we can sub 0 and 0 in for x and y, okay, and solve for a. So we go 0 equals a times 0 take 4, so that should be squared, squared, take 10. Okay, so 0 equals a, 4 squared, take 10. Okay, so 0 equals 16a minus 10. Okay, so 10 equals 16a, so 10 on 16 equals a, so we can make that a equals 5 on 8. Okay, you make sure you simplify your fraction. Okay, we're not finished, you can't just leave it there, you need to say therefore y equals 5 on 8, x take 4 squared minus 10. Okay, so we need to make sure that we actually, even though we've got all the information here, that we put it all together, okay, in the end. Okay, because it's asked us to find the equation of the function below. And whilst you've got all the information here, you haven't actually answered the question that's being asked. Okay, so there's just a couple of examples of some of the information that we've come across in this tutorial and how to utilise it.